Good morning everyone. Myself Dr. Trina, Assistant Professor, Chemistry Department, JIS College of Engineering. So you can see here I will take the chemistry class and already you have got your routine. And in last two lectures I have told you about the application of polymers, different structure of polymers, and the classification of polymers I have started, and I have covered the based on classification, based on origin. Number 2, based on chemical structure. And tacticity. These parts already covered. So today I will complete the rest of the classification. So today I will tell based on line structure. So based on line structure, this is of 3 types. A, linear structure. Linear structure means the structure of polymers will be like this. So example is HDPE, high density polyethylene, HDPE. So you can see here that in the line structure, in the linear structure, there is very small space in between. They are stacked such a way there is almost no spacing. That is why the density is higher. Density means you know that mass per volume. So if you see the branch structure, you will be more clear. So branched polymer, what will be the structure? So this is the branched structure. So the example is LDPE. This is low density polyethylene. So low density polyethylene, why density is low? If we consider a mass per volume, the mass per volume. So for the high density polyethylene, we get the higher mass for the same volume. That is why the linear polymer are arranged and the density is higher. But the branched polymer, the density is lower. The example is low density polyethylene. The third one is 3-dimensional network structure. That is, the example is bakelite. You have seen the structure, that is very complicated structure. It is the 3-dimensional network structure. So it is very complicated structure. The example is bakelite. So next basis of classification is the formation of polymer. So based on Based on formation of polymer, polymer is of two types. Number one, addition polymerization. Number two, the condensation polymerization. So addition polymerization, I am showing you the example. This is the ethylene. We have to take n number of ethylene. N number of ethylene. Now after polymerization we get polyethylene. So this type of polymerization is called addition polymerization. So in this type of polymerization there is only single type of monomer. And after the polymerization we get the formula, the empirical formula is same with the monomer. And number three, there is no loss of any molecules. Next is condensation polymerization. So condensation polymerization I am showing you by the example, that is formation of nylon 66. That is a nylon 66 is a condensation polymer. So what are the monomers of the nylon 66? Adipic acid and hexamethyl diamine. Acid means always it will have the carboxylic group. So there is two carboxylic group, CH2 whole 4, then COOH, another is C, that is the adipic acid. Now plus hexamethyl diamine. So plus hexamethyl. Hexamethyl, so we have to take 6 number of methyl group. Now diamine, that means 2 amine. So what happens? So hydrogen from the amine group and OH from the adipic acid carboxylic group combine together and left as H2O. Same way this hydrogen will be left with another OH group as H2O. Here the OH will be left with another hydrogen group. So of course there will be n number of adipic acid and n number of hexamethyl diamine. Then what will be the final structure? The final structure, just remove this OH and H as H2O. Then we get So this is the final structure of nylon 6,6. So what are the characteristics of condensation polymerization? So number one, that there are different types of groups. The monomers are different. More than one type of monomers are involved. Here you can get the two monomers involved, adipic acid and hexamethyl diamine. And the empirical formula is different from the monomers. And there is a loss of small molecules like H2O or HCl. Next, classification based on thermal response. Based on thermal response, polymer is of two types. One is thermoplastic polymer, another is thermosetting polymer. So what is the basic difference? It is a thermal response. That means if we apply heat energy, how it will respond. So if we apply heat energy, thermoplastic polymer will soften, and if we remove heat energy, it will become hard. But for thermosetting polymer, it does not soften, it becomes harder. So next is, so you can understand very easily that thermosetting plastic polymer can be recycled, can be remolded, but thermosetting polymer cannot be recycled or remolded. And if we apply the heat for longer time, upon application of the prolonged heat energy, the thermoplastic polymer will melt, but thermosetting polymer will burn. So why it happens? Why thermosetting polymer becomes harder? Because of cross-linking. Cross-linking means, if say we take the natural rubber and we are doing the vulcanization process. So it is say the chain of natural rubber. If we apply heat energy, then more cross-linking will take place. That is called cross-linking. You have seen in the bakelite also. So if we apply heat energy, there will be more cross-linking. So the structure will be more complicated. The molecular weight will be increased. So it will not melt. So that is the thermosetting polymer, which generally we get by the condensation polymerization. But thermoplastic polymer, generally it is either linear structure, you have seen the linear structure, or the branch structure. So the thermoplastic polymer generally formed by addition polymerization. The examples are like polyethylene, polypropylene, polyvinyl chloride, etc. But thermosetting polymers, the examples are bakelite, vulcanized rubber, etc. So these are the thermosetting and thermoplastic polymers. Now, you have learned the classification of polymers on different bases. Now I will tell about different types of polymer. One is conducting polymer. So polymer generally non-conducting by nature, but there are few polymers which are conducting by nature. That means which have the metallic property. It may be intrinsic or extrinsic. It is like intrinsic or extrinsic semiconductor. And conducting polymer, the example are like polyaniline, polyacetylene, etc. Example: and this type of polymer we can apply in different fields like supercapacitor, to build supercapacitor, to build solar cell. For the LEDs we can use the conducting polymers. Next is biodegradable polymers. It is very much important because you know that plastic pollution is the great concern. So we need to invent the biodegradable polymers. The polymers are generally non-biodegradable because of carbon-carbon bond, which are non-breakable. That is why it lasts for long years, and that creates huge amount of pollution and huge amount of solid waste which need to be disposed. So disposal is very great problem. So biodegradable polymers we require it. So example is like polyglycolic acid, polyhydroxy acid, etc. So from the biomaterial we are nowadays making the biopolymers, like from potato peels or different banana peels we are trying to make. So we have to think about biodegradable polymers, and we have to invent more useful this. Like plastics is used for packaging purpose, and that is very user friendly. So we have to make such type of biodegradable polymers that is very much user friendly and can replace the plastic materials. Plastic materials are now being banned in different areas, but we are not getting the proper replacement of this. So we have to think about all these things. Okay, so if we summarize the today's lecture, so what you have learned? Number 1, classification based on formation of polymer. Number 2, thermal response. Number 3, line structure. Number 4, conducting polymer. Number 5, biodegradable polymer. Okay, so all these things today you have learnt. So if you have any doubt, you can communicate with me, and you upload your assignment in test.com, and I have given the code. Again I am reminding you that DMBC, there all the assignments are given. So check it and upload this assignment by tomorrow. Okay, thank you.